All right, welcome everyone. Today is Thursday, the 14th of September, 2023, and this is a sub-project meeting of the Cluster API project. We're going to be talking about the Karpenter autoscaler and what we might think about doing with it. This is a sub-project of Kubernetes SIGs, and as such, we follow their meeting guidelines, which basically means please treat everyone as you would expect to be treated. And I'd say raise your hand if you like to talk, but there's so few of us, it probably won't be a big deal. All right, yeah. So welcome everyone. I think we're all here because we're at least curious about Carpenter. And so I wanted to get a meeting put together so that we could start to talk about maybe what we would like to do as a community with respect to Carpenter. If there are use cases people have right now that they're going through or things that they would like to do with it. So really, I'd just like to have a conversation with you all and kind of get people's thoughts and everything. Um, so yeah, like what are people looking to get from Cluster API and Carpenter? What do people have plans already, or are people already thinking about things?
I can go, I guess.
Yeah, please.
We've started to play around with running Carpenter in some stage clusters to see like what kind of savings it would really drive for us in terms of running our workloads. Um, and then we, Mike quickly picked up on the fact that like there was no way we could use Cappy's node lifecycle stuff along with Karpenter because Cappy and Kappa have no idea that those nodes even exist. So that's kind of where we got to, and we're like, okay, well, we think this is going to save us some money. That's good, but we know that there's probably a fair bit of work with Cappy and Kappa to get all of these three things, well, really two big projects to kind of play nicely together. Which is why I think Mike started to kind of bring it up to the Cappy meetings.
So it sounds like so far you've been trying out like you want to attach Carpenter to a Cluster API cluster and kind of see if you can work out how to get it to like manage the cluster for you, or have you gotten that far, I guess?
Yeah, so where we started was we threw Karpenter onto some non-Cappy managed clusters because that seemed to be the most obvious thing to do first, and look at like what is it really going to materially save us? Like, can we quantify the the value of swapping autoscalers? And then what we did is we stood up a Cappy Kappa managed cluster and then flung Karpenter on that just to check to make sure like the world didn't end for some bizarre reason that we wouldn't have expected. And it did not. So that is about, and there's like no real workloads running on those Cappy managed clusters at this point. So it's like not even, it's like pre-production dev sandboxy types of setups. So that,
Thing,
go ahead.
sorry, Dan, one thing that's worth mentioning on there, these are EKS clusters as well.
Yeah.
Okay, cool.
So yeah, so that's what we were doing. We were pulling out the CAS. We're removing the regular cluster autoscaler and adding Karpenter onto both of these types of clusters. Sorry.
Can you hear me now?
Yes, we can, Pao.
Cool. Yeah, so I
Or
can
Dan,
give
sorry.
similar input from the Swarm side. We are migrating from our own, let's say, way of provisioning clusters to Cappy. And our main goal is for the same reason, cost savings, but then it's much easier also to manage multiple instance types. I just don't care which instance type it's used. I just want to fit multiple of them. To give an example, for example, you can do like a machine deployment, but then maybe Prometheus doesn't fix, so you need to now create a new machine deployment. So it's a little bit much. You get out of your mind which instance type do you need to use, right? As far as testing it out, we've made Karpenter work with Cappy, or with Kappa, exactly, using the machine deployment launch templates and the subnets, and so everything that's provisioned by Kappa, and we just plug in Karpenter to reuse the same subnets and the launch template to manage the instances, which works fine. The only, I would say, problem here that needs to see how it could be solved is how can we create these provisioners from the cluster definition itself, right? Because right now this is all like hidden to the Kappa controllers. And also, if you look at the resources, the cluster and the from the CRs itself, you cannot see how many machines the cluster has, so you cannot read the information about the current status of the cluster, because the default machine deployment is basically scaled to 0, basically.
I think it sounds awesome that people are already trying to integrate Kappa and Karpenter. Like, I think it's really cool to hear that you folks are doing that. And I think like, yeah, like this is going to be the tough part and why I kind of mentioned the managed Kubernetes stuff to begin with, because like, yeah, like maybe there's some way that we can get into this activity where we could have Karpenter running in Kappa and then we could detect, you know, the nodes or something. So I think it's really cool to hear that there are at least a couple different groups out there that are already trying this out. Are there any other yeah, Dan, please go ahead. Oh, you were
All right, got into a giant mute cycle.
okay, cool.
So we actually spoke with the Karpenter guys, guess yesterday or 2 days ago or something, and they're looking to actually deprecate the launch template stuff. So just a heads up that they actually want Karpenter to manage the launch templates. We have done a very similar thing in our testing of Kappas. We just basically like tag all of the stuff in the cluster in a way that then Karpenter can just like find it, right? It has like a sort of a discovery feature for looking up subnets and security groups. So that seems to work well. And then I guess my question back to the Giant Swarm folks is, so you guys are, the fact that like Cappy can't see how many nodes Karpenter has or how it's managing them, like that's sort of like, you don't really care much about that. It's fine for you just to be like, okay, we've got Karpenter running on a managed node pool in Kappa. We scale everything else down to 0 somehow. And then Karpenter takes control and the management cluster has no clue about any of those nodes. That's kind of your going in position. Just, I want to make sure I'm clear.
We're going there because, I mean, with the current status that we have, right? I mean, we're not expecting to be in like full production mode in the next few months, but we would like to have that status, let's say, because we are pushing for GitOps into our customers, right? So we're gonna be like in a in-between state where customers cannot fully define their clusters in GitOps. But yeah, there's gonna be this hidden part where we create the provider or the provisioner, sorry, inside the workload cluster.
But is your end state that you're okay that the management cluster doesn't have visibility to like the number of, let's use Kappa, Cappy language, the number of replicas that Karpenter is running at any given time, right? Because like, is that okay as like an end state, or do you think like, no, we need Kappa and Cappy to like have knowledge of what's actually running?
I think that would be the best, right?
Okay.
Just because maybe some toolings might read that data, and right now it's going to be the wrong value. I think for now we can survive without that data. We're not using it yet, but it's in the idea world we have this representation in CR somehow. Even if it's read-only, right? Because in the end you don't define how many machines you want in Karpenter. You just define maybe RAM and CPU, right? Even if it's just that, that would already be useful enough.
Yeah, I think it's interesting to note that there might be cases where, you know, where the users or operators don't care about the cluster API objects. And so they're like, yeah, just let Karpenter run. Like, you know, those might be edge cases, but I just think it's interesting. So I guess, are there, yeah, Jack, I see you got your hand up. Please go ahead.
Yeah, how are folks, so in the, basically, we seem to be describing a kind of bring your own node scenario integration with Cappy, where Cappy provides the control plane and Karpenter in this case is the bring your own node solution, but you can imagine that being super general. How are folks getting kubeadm join tokens to work? How do you do bring your own nodes in Cappy? What's the workable solution for that? How are you actually joining those nodes to the cluster?
So the
Yeah, great.
You
I'd love to hear
can.
from anybody.
So for us, we point at an instance profile, and that instance profile that's actually generated from the Kappa cluster build. Karpenter just adds that instance profile to all the EC2 instances that it manages. So then it's getting the ability to join the cluster from that side.
So you kind of inherit it from so that profile is a sort of recipe of a real VM implementation, and the kubeadm privileges, all the tokens are present on that like VM image, so to speak. It's basically like you're inheriting that VM image and then replicating it out.
Yeah, correct. Yeah, so like my like little chunk of booting up Karpenter basically like reads a bunch of stuff from the Cappy management cluster, squirts out a values file for Helm for Karpenter to then install Karpenter. So that's pretty much what I'm doing, is I'm using the Cappy cluster as like a basis for what Karpenter needs and then bootstrapping Karpenter via that. That's just what we're doing at Adobe. Just
yeah, cool. No, that makes sense. So that's a totally valid hack. So I assume you're keeping the kubeadm surface area totally static in Cappy, because as soon as you updated that configuration, then those new nodes would not be able to join because they would have.
Yeah, correct. There's no like I have not yet, although this would be an obvious way of just, swinging it first, is to like write a controller for some of this stuff that also runs in the Cappy cluster that then manages the provisioner definitions and AWS node templates, which are the two Karpenter constructs that come together to, sorry, I don't know where everybody is on Karpenter knowledge. So like those are the two pieces that come together. So like, yeah, that would probably be the first obvious swing that like we would take potentially before even like pitching a change in Cappy. Although I think we would probably do both of those things at the same time. The folks building that operator would probably trying to look at what to do in Cappy as well at the same time, or Kappa at the same time.
Cool. So someone else was going to share.
Sorry.
A war story.
From our side, I think I already said that we use the autoscaling group, and that means we use the launch template, I think it is, that contains already the tokens that gets, let's say, managed by Cappy or Kappa itself.
Cool. So essentially the story is you can create a cluster with Cappy and then sort of freeze its configuration forever. And then so long as you don't update the control plane configuration, all the nodes that were initial, so you build a Cappy cluster, which builds a few nodes to start, freeze the configuration, and then you inherit the node configuration from Cappy and apply that to the Karpenter configuration for nodes.
You don't need to freeze it.
You're good to hack.
You don't need to freeze it really, because Karpenter will always use the latest launch template, and that you can always create nodes with that, right? So yes, you don't actively manage anything anymore except the control plane, kind of. But you are able to create new machine deployments. You can create anything else. It's just that we dedicate one machine deployment to Karpenter.
It sounds like a valid functional prototype where you could do some A/B testing and actually prove out the hypothesis that it's cheaper to run Karpenter compared to cluster autoscaler, because I assume everyone else is running cluster autoscaler. That's the baseline that you're trying to get cheaper against, right?
Yeah, I mean, we did that test, like not using Cappy, because like, what's the difference? A Cappy managed cluster versus like a non-Cappy managed cluster. The workload is what drives the cost.
For sure.
So we actually did that on two different clusters in two different regions in our system. So yeah, and granted, they were only stage clusters. They're not. They're not diverse enough in what they're doing to correctly represent the totality of our fleet, but they are interesting enough that it has caused us to prick up our ears and say, maybe we really should do some work here.
You got convincing outcomes that this is going to save money.
Yeah.
Yeah. Cool.
And one thing let's say another thing that Karpenter solves issues is basically spot instances, right? I'm not sure how spot instances implementation works with Kappa yet, but the issue that we have in our product is that if you manage spot instances with SIGs, the moment you try to upgrade the cluster and there's no spot instances, everything fails and it's a hassle to deal with, right? And the cool thing with Karpenter, if you skip the SIG completely, spot instances are much more usable.
Yeah, that's probably going to be a Kappa comparison. So I think Karpenter is really analogous to any single provider. Like when we say Karpenter, we're talking functionally about the AWS Karpenter or the EKS Karpenter. And so you would compare that to how does Kappa manage spot instances? Kappy doesn't really care about that. It's more the
Kappa, yeah.
actual last mile of what do I do as a provider implementation when I lose, like a VM disappears, for example, because that's what happens. That's one scenario with spot instances. Another scenario is you try to get 5 VMs and you don't get them. So you have to retry with, say, different. These are all the things that Karpenter probably does really well. So Kappa could do that well, but it would require lifting and shifting that logic into Kappa. Someone was raising his hand.
Yeah, Dan had his.
That was me. Just be aware too that Azure has been making noise that they are interested in Karpenter as well. So that it may seem today that it is only Kappa, but
I'm very aware. I work for Microsoft, so.
Oh, okay. Yeah, sorry.
Yeah.
I just couldn't remember who everybody.
Yeah, I have virtual coffee with the folks who are.
Yeah, I think they just spoke. The Karpenter guys from AWS, I think, just must have just spoke. They said they were speaking to the Azure guys like on the regular.
Yeah. If you
But
don't
I mean,
mind, Jack,
I just wanted to make the point.
attendees list.
I just wanted to make the point that Karpenter is actually very analogous to Cluster API in the sense that you have an API defined and then implemented in a provider specific way across providers. The only difference being that, as you say, Dan, the provider ecosystem in Karpenter is still emerging, but the architecture is there. And so the reason that Karpenter only works in AWS isn't because there's a single monolithic Karpenter project. It's because there's only one provider as of right now that is readily available that you can use, and that's the AWS provider.
So
I think
sorry. I was just going to say, like, this seems like a great topic now to kind of like a great point to kind of switch topics, you know, from kind of like what are we looking to get out of it to kind of what I think is the next big question. And Dan, I'll give you a chance to kind of finish your thought here before we move on. But just to kind of get people thinking, I think the next big question in my mind is kind of like, what do we want to do? Like, do we want to build a cluster API provider for Karpenter or provisioner for Karpenter, or do we want to kind of lean into the Kappa approach and build some sort of managed mode? So please, Dan, finish what you were saying, and then we'll start to move on.
Yeah, I guess the other thing we haven't tested, which then also I think somewhat dovetails with where you're headed anyways, is that one of the things we haven't really worked on at all or tested with Karpenter is like Karpenter's understanding of node drift, which then begets you a certain amount of node lifecycle. So you tell Karpenter like, hey, I want to change the underlying AMI, you know, I'm going to upgrade the OS, if you will. And like, how does Karpenter manage that drift and then slowly or quickly, we haven't tested this yet, like swap your workload nodes over to that new version? So like, this is where now Karpenter starts to run up like directly into some of the stuff that, you know, we think is particularly interesting in Kappy, and we think of as like the one-stop shop for managing the state of the cluster, where we have cluster operators. It'd be great if they just worked with the management cluster, right? They didn't have to jump to the workload cluster and muck around with the nodes. They could do it all in Kappy. But obviously today with that like sort of bring your own node kind of thing that it seems like we're all landing on is being further and further removed from that kind of like one-stop shop for management. So that was the only other thing I had. Thanks.
I think Lorenzo was raising his hand earlier too.
Oh, cool. Yeah, like Lorenzo.
Oh, yeah, it was just what Pau said about our use case. So that's fine. Thanks.
Okay, cool. Yeah, so like, you know, we've been going about 20 minutes on that topic, and I think it's a great discussion there. We could probably fill the whole hour just talking about our use cases. But in the interest of kind of like where we're going in the future here, do people have thoughts, or have people thought about, should we maybe internally, people have thought about building cluster API providers for Karpenter? Or about a year ago, just for a little background, year and a half ago, I started going to the Karpenter working group meetings. And I started trying to build a cluster API provider for Karpenter. I think at the time, Karpenter was in a less mature state than it is now. And I had some trouble building it, but that was probably more on me. But now the community has become much more mature, and I see that their documentation kind of talks about this a little more. But I think from our perspective, we could have a community-centric kind of collaboration where we build a common CAPI provider that we can all kind of work on and own and everything. Another approach to this, though, given that we have a managed Kubernetes feature group, is that, we could try to do more work to just allowing people to run Karpenter as they see fit and make sure that Cluster API can be aware of that. And then that kind of opens the possibility for, maybe if people want to write an Azure provider for Karpenter, then perhaps Cluster API could consume that through some sort of managed mode or something. So I'd like to open the question up to the group here and see, like, have people been thinking about this? Have people been investigating it? What do people think about this? Should we do something as a community here? Jack, please.
One point I wanted to probably get some conversation on and thoughts on is, I don't know how we do a CAPI provider for Karpenter. I think we have to do a per provider for Karpenter. So there would be an AWS provider, a Karpenter AWS provider, there'd be a Azure Karpenter provider, there'd be a GCP Karpenter provider. The way that I've been thinking about it is that the CAPI API would inform the data input surface area for the Karpenter provider, and that's going to be very provider specific. And so I would be interested if someone has some real mature thoughts on how to, or even just napkin thoughts on how to do a pan provider for CAPI where it covers more than one cloud platform.
My personal feeling, and this is what I started to work on, like a year ago or whatever, is that if we wanted to, we could build a Karpenter provider that operates at the CAPI machine set, not machine set, but like machine level. And I started to look into how we would build that from the perspective of, like, matching it to the resources we had at the time, right? So like in the Karpenter interface, right, there's a notion of like the core Karpenter parts can ask the provider, like, what instance types do you have or whatever. This is like one example. And so I was doing something where it was like, I was going to make, like, when the user sets this up, and this would be like really cumbersome. So like, hopefully we'd think of something better in the future. But like, when the user is setting up a CAPI provider for Karpenter, the first thing they do is define a bunch of machine sets or machine deployments that are like, these are the available machine types that Karpenter can use, right? And then the provider, when it was getting requests from Karpenter, depending on the instance type, then it would try to increment that specific machine deployment. So the provider was keeping like a mapping between the instance types that it was giving to the core library of Karpenter, and then doing the actual like replication, like increases and decreases based on what Karpenter was asking for. Now, based on the kind of the code structure of Karpenter at the time and the way that it worked, one of the things that I was seeing was that it's just a very long loop for Karpenter to, like, say, I would like to create this instance. And so it increases the replica count on something, and then that goes off and creates the machine. And then there's kind of a long feedback loop to come back there and then report back to Karpenter what you're doing. And I think that area requires more research, like, especially since the code has changed since then. But I think there's definitely a possibility that we could create a generic CAPI provider that manipulates the actual CAPI objects. Now, my personal feeling is, I think the downside to that is that you would not be able to get cloud-specific performance increases in the same manner as if you had specific providers for each cloud. So I think, Jack, your idea of a provider is very interesting to me. And I see.
Well, what you say I would suggest that you would have the, say, AWS machine and Kappa, all the Kappa controllers already running on that cluster. So Karpenter would call into Cappy to build a new AWS machine in the Kappa case. And then
Right.
Kappa would do all the work of building that machine with the particular, VM configuration that Karpenter determined for that. Is that what you're suggesting?
Right. Like imagine, and Pao, I see your hand up. I'll come to you after we got to go through this. Imagine I create a Cappy management cluster, right? And I create 10 different machine deployments for the 10 styles of machines that I would like to have auto scaling in that, maybe different, whatever they are, right? And then
can you unpack that a little bit? So what's an example of a type of machine style?
So I'll go with so I create one machine deployment that is making like 4 CPU 16 gig machines, and then I create another machine deployment that is creating 16 core 128 gig machines, and et cetera. Each machine deployment is a different shape of machine, or perhaps the regional stuff probably is less important, so I don't want to get into those kind of differences. But let's just assume that you were making machine deployments that each described a different kind of shape of machine, right? And I'm going to specifically leave out machine pools for the moment, because machine pools probably is the perfect interaction between this. So each machine deployment describes a single type of machine that it could make, and we then, through the provider interface, give that information back to the core Karpenter. And now Karpenter says, I've got these 10 different kinds of machines I can make. And so whenever I'm choosing to grow or shrink the cluster, this is the palette that I have to choose from. And so when Karpenter calls back into the provider, it says, I need to make like 2 of instance type 3 or whatever, or I need to drop 1 of instance type 1 and create 2 of instance type 2 or something. And so in that respect, we could keep this kind of mapping between what is happening in the core Karpenter and the instance types that we provide through it can all come through just the normal cluster API CRs. And then the provider in Karpenter is really just manipulating like the replica counts on those things and providing like a status kind of mediator between the core library and whatever is actually happening in the cloud provider. Does that clarify it any?
Yeah, I think so. Let's let Pao add his thoughts.
Please, Pao.
Yeah, just the first question would be, you're thinking about running Karpenter on the management cluster, right?
Right. I think by default, I would assume, you're running Karpenter in the same place that the cluster API CRs are installed.
Okay, because in our case, we were always thinking about running it on the workload cluster that we create, in a sense.
That'd be cool too, right? Like I would want to create the pattern we have in the cluster autoscaler right now, where it's like you can give it 2 kube configs, one for the management, one for the workload, because it's going to need them anyways. And then you can run it wherever you want to. If you want to run it on the workload, run it on the workload. Yeah, I would want to create that kind of flexibility.
Yeah, because in our case, our, let's say, first thought implementation would be that Karpenter gets installed into the workload cluster, and then the Cappy, or let's say the Kappa work is to provide this infrastructure somehow that we need for the Karpenter machines to work, and then create the provisioners, basically kind of based on a definition of a machine pool, right? So you have like Karpenter machine pool, and what that means is you will get a provisioner in your workload cluster that Karpenter will use to create the machines, right? And then it will also read back the instances that have been created or whatever, but it's basically all done in the workload cluster.
So let me make sure I understand what you're saying here. So that would be a situation where you're running it in the management cluster, and or in the workload cluster, and when you start Karpenter, it would choose a provider based on whatever the cloud provider in that workload cluster was. And then that Karpenter provider would have the ability to create machine objects then in that cluster. Is that?
not really machine objects. It would create the, well, it could create the provisioner, and then it would create the machine objects, yes, on the
Okay.
management cluster.
So it would
To
create the
represent the
instances
machines.
and then also inject machine objects. Now, would it try to put those in with like machine sets and machine deployments or whatnot, or would it just be putting them in as machine objects?
I would say if we have this like Karpenter machine pool, the information could be just stored in the Karpenter machine pool itself. I mean, I'm not sure if are the machines inside the machine pool also represented as machines. If they are, I would say we should do the same thing. Otherwise, don't really need the machines themselves.
I think this is a new feature coming for machine pools, right? So the actual machines get represented as objects.
Yeah. Then I would say to follow the same rule that we have for the normal machine pools, kind of.
Okay, Jack, I see you've got so Dan, you've got your hand up, and Jack has a really big question in chat. So Dan, please, why don't you go next, and then we'll come back to Jack's question here.
Yeah, I just wanted to like plus one what Pao was saying. We have the same sort of very similar vision as, and like I'm a total neophyte in the CAPI source code. So, but that was the weak, not the weak point. That felt like the right spot for us too, where we would have some we'd bootstrap the cluster in CAPI. Karpenter would be running inside the workload cluster, and then it would either through the machine pool reconciliation process be able to find the nodes that Karpenter is creating, or directly fiddle with the Karpenter machine pool in CAPI as sort of a not like a finalizer, but like as it's one of the last couple of things that it does once it sees a node is provisioned and then ready, and then so Karpenter would be sort of responsible for the node lifecycle and the status of the machine in the CAPI cluster. So that was kind of my like very like Jack said, anybody have a napkin idea? That was like 2 beers and a napkin. That was roughly where I got to in all of this.
Yeah, well, and I think it's really interesting too, because like my 2 beers and a napkin math took me in like a slightly different direction.
Yeah.
So I think we have, in my mind, what this means is we probably need to do a little research into Karpenter code and the CAPI code and figure out like what makes the most sense here. Because I do like this idea of like running in the workload cluster and then installing some Karpenter provisioner that's very specific to that. And if that's the way the community wants to go, that I think, that could be very cool. I was originally thinking at it from a perspective that's very similar to the cluster autoscaler we have now, which just manipulates the CAPI objects. But maybe that's not the best approach for Karpenter. So I want to read Jack's question here from chat because it's pretty big and it looks interesting. So Jack is asking, Mike, you're describing a pan cloud K8s cluster. Very interesting. So Karpenter has knowledge of a set of machine deployment flavors, each of which has a particular infrastructure ref config. In this case, there's no reason why your set couldn't include AWS machine deployment records, Azure records, GCP, etc. And if your CTO goes golfing with Sundar and you get a preferred pricing on GCP compute, you can update your Karpenter GCP machine deployment definitions and expect to see your cluster build more GCP nodes. Yeah, I mean, build more GCP nodes going forward. So like Jack, yeah, I think like you're picking up on what I'm laying down here. One of the things that I'm kind of interested in, right, is a future where we might have hybrid clouds, or hybrid cloud clusters. And I think we're certainly seeing users who are interested in this pattern. And it's like, I think it's going to take a while to get there, but yeah, to your point, Jack, like, yeah, I think like operating at the cluster API CR level will allow us to do things like that. So if we ever get to the point where you have a cluster that you could deploy that has like 2 CAPI providers in it or something like that, or you've got a hybrid cluster that somehow spans cloud infrastructures, then yeah, operating just on the CAPI objects would allow us to keep Karpenter from having to know the specific cloud interfaces and could just work with the CAPI stuff. So I think that might be interesting. That was kind of what interested me in that approach. It was just how abstracted it was.
Thank you for spending some time on that, chat. I think the hard part, but the fun part would be getting all the, because this would be super dependent on very particular cloud provider. So when I say GCP, I really mean CapG, and CapZ and Kappa. And so we would need to build something that had each provider that we would include in an effort like this would need expert contributions from that provider community to ensure that the sort of correct plumbing is installed in the new Karpenter provider. And obviously, as a user of this, you would need to install the controller runtimes for each CAPI provider into your management cluster that you're doing this on. So if you expect to be able to use GCP and AWS nodes in this cool new Karpenter cluster enabled world, you would have to have the CapG controllers running. So you do your cluster init, cluster CTL init, CapG, cluster CTL init, Google, cluster CTL init, Azure, AWS, etc. I'm just talking out loud. It's early for me too, so
Yeah, no, and thank you so
helps
much.
me to repeat things.
Yeah, like I know this meeting kind of like it's early on the East Coast, but I know on the West Coast it's even earlier. So, what you're saying makes sense to me. And I think that's a good point to think about too, like kind of the maintenance long tail of this, right? Because you're right. Like if we make a generic approach, and it's like, well, Karpenter's looking great on Azure, but someone shows up and they're seeing a bug that only happens on GCP, then we would obviously need to get the CapG people involved, and they would have to look at it and kind of figure out what's going on. And that might be, I don't know if that would be more or less difficult in a situation where we have a common provider versus like separate providers. But yeah, I love that we're kind of talking about these ideas, and maybe, as we go forward in the future here, we'll start to think about, okay, is like I think there's more research that needs to happen, and then kind of figure out like which direction do we want to go here with this stuff. Because another thing I could think about as well is like, as machine pools are coming into Cluster API, the machine pool is actually a perfect fit to plug into Karpenter, right? Because a machine pool already encompasses like a group of machines. And if there were a way for the logic in the Karpenter provider to surface from the machine pool which machines are in it, and then it could provide those instance types back to the core logic, like there might be a way to build some sort of bridge there between the two. And then if we could promote more Cluster API providers to build machine pool implementations for their provider, that's kind of like another direction we could go here. So I think, like, in my mind, there's just like a lot of really cool stuff we could do. It's really a question of we need to kind of figure out which one makes the most sense for us.
The only problem there is machine pools are different across cloud providers. So
gotcha. Okay.
It puts the burden on CAPI to do that standardization. CAPI would have more burden to create abstractions that were able to represent all different types of sets of machines. Azure, AWS, GCP do them all a little bit differently, whereas VMs are a little bit easier to create a common abstraction on top of.
Yeah.
How are you raising your hand?
Yeah, Pal, please go ahead.
Yeah, it's just about, I think the problem also lays in understanding how future, let's say, cloud support will work for Karpenter, right? I mean, right now, Karpenter needs to ask for the price of the machines, right, to be able to choose the cheapest one. And then also, you will have some, let's say, demands from the pods that they need certain features, right? Maybe availability zone. So I'm not sure how can I envision Karpenter supporting multiple clouds at the same time. I'm not sure that's going to happen, let's say. And in any case, I could imagine that this could also work on the provisioner abstraction where Karpenter works on the workload cluster, right? I could see Karpenter just has a provisioner which is in AWS, another provisioner that works with GCP, and it should be able to provision also machines in all the different clouds. But I guess we need to get the details on how that's going to work with Karpenter upstream to think about that. I mean, I think that problem is a little bit more complex, right? Because we need to think about how we set up networking between clouds and like a lot more stuff than just provisioning nodes, right? And I have no idea on how that will look like and if it's ever going to be there.
You're asking the hard questions about it. It's not fun.
Yeah, yeah, totally. +1. You like excellent,
Let's just
excellent
say you can
insight.
do this super cool, but you don't have networking. Let's just drop that. That's not part of the MVP.
Like
Totally.
we can boot machines, but we don't have networking, right?
Right,
We
right,
get the
right.
machine, right?
Yeah, good call out though. Good call out. So it sounds like we have a lot of topics here. And does anyone else before, like, I was going to kind of move on to think about like what we want to do from here, unless anyone would like to kind of keep talking about some of the options. It sounds like there's enough interest here that maybe we need to do a little research and figure out what's next. But like, do we think there's enough activity that we might want to form like a reoccurring group? Maybe we could meet once every couple weeks or once every 3 weeks at this point, and maybe start to think about, if we do some research now and investigation, we could come back and start to share ideas. And maybe there's a way for us to build a common piece of code or documentation or something that could help our cluster API providers to better interact here, or to at least provide like kind of a community response to what we think about Karpenter. What do people think about that? Yeah,
I would say from Genstorm, we're definitely interested in this. We're going in that direction, and we have always kind of worked in open source. Usually it's more on the Genstorm side, but I think we want to contribute this upstream and sharing the ideas with you all. I think we will get in a better spot.
cool. That's great to hear. Dan, please.
Yeah, I think, this is top of mind right now at Adobe. We are pushing multiple vendors on this front around Karpenter, and we have a large initiative to move a lot of stuff. You've seen Mike be very involved in all of these things. So yeah, at Adobe, this is definitely an important thing. We would love to have these two projects play nicely together, and we are, I think, interested in helping out where we can.
That's awesome to hear. And I see Jack saying +1 as well. And I'm a +1. So why don't I do this? I will look into maybe setting up. Let's try and set up a poll for a meeting time that maybe works a little bit better than 9 a.m. on Thursdays or whatever. We can kind of discuss that over the next couple of weeks through the regular community meeting. But why don't we take this back to the regular community meeting next Wednesday? Talk about that we're going to set up a feature group to decide, like, to try and provide guidance on what we're going to do with Karpenter. And then Jack like just added this to the chat, and I'll read it here because it's kind of exactly where I was going. I would like to see us come up with a cape that describes how Karpenter provider would look, and then choose one cloud, probably AWS, to implement first of all of this general Karpenter provider implementation, assuming that's the direction we go. I think that's totally awesome, and I agree. Dan, please.
The other thing I think would be useful to bring up is that it probably would be nice to actually speak to some of the folks from the Karpenter team, because I know that they have some big thoughts around what Karpenter should be doing and where it should land in the broader Kubernetes ecosystem. So it would be nice to sort of understand where they're shooting towards, so that we are in line with where they're going about just design decisions that we're making around what CAPI or Kappa should do. So I got a little taste of that a couple days ago, but I think it would be nice to hear it from them.
I'm on the working group that's talking to SIG Autoscaler about that, Dan. So I can maybe answer some questions if you have any questions right now.
I don't at this moment, but like, as long
Cool,
as someone that's associated with this group is well informed about what is happening there, because to me it's like there's these things happening and we're trying to sort out where everything's going to land.
Yeah, I mean, the TLDR is that Karpenter is in the process of donating to the CNCF, and the devil's in the details. But that process is ongoing in real time in the background right now.
I think that's thank you for bringing that kind of information back and everything too, Jack. I've been following the document that y'all have been working on there, and kind of just observing what's happening with the process. And I think it's really cool. But Dan, to your larger point here, yes, I think you're absolutely correct that we should definitely be reaching out to the Karpenter folks. I used to go to their working group meetings, and I think it's a good place for us to kind of talk about this stuff. They're very friendly. I've always been very welcome there, and I thought it was very cool. So I would say like that would be a great next step is maybe, yeah, like let's start going to the Karpenter meeting and talk about that some more. I talked about the cluster API provider with them, like I said, probably more than a year ago. Everyone there was very welcoming to me. So I would say like, yes, let's do that. And whether we do it as a group or people just go there and kind of talk about this, I think both are awesome. So yeah, I'm totally on board with that.
Yeah, so from my side, I just wanted to share that we've talked with ADS people when working with one of our customers and with the Karpenter people. And I think we could also talk to them to make sure that at least we have some representation from them in here, because I think it's really useful to have the
Yes.
knowledge on Karpenter directly.
Absolutely. And we at Red Hat, we had we've been talking with the AWS folks as well, or one of their Karpenter teams. And I actually reached out and sent them the doodle polls for this, but I'm guessing maybe the times didn't work out or something. So I've been trying to keep some of their like project managers in the loop in terms of like inviting them to these meetings and whatnot. And I think like probably, yeah, one or multiple of us should probably just start going to a Karpenter meeting. And when we figure out what our cadence is, then we can share it with the Karpenter team and say, hey, look, here's how we're going to progress. And maybe there's a way we can collaborate even between our organizations, basically between our groups, you know. All right, so I've got the links in the agenda. I will take this recording and post it to YouTube, and I will link it back to the main CAPI docs, CAPI meeting agenda, as well as putting it in this document as well. Is there anything else folks would like to add before we close up here? Yeah, Jack, please.
The next Karpenter working group meeting is in 2 hours. So pre-installed AWS Chime and show up if you like.
Cool, thank you,
But-
Jack. I'm actually
budget
on
at least
PTO
15 minutes to install a novel AV communication tool on your device, by the way.
Right, exactly. I'm actually on
Assuming
PTO today, so I'm going to like take off after this meeting. But like, I look forward to seeing all the exciting things that come out.
What a wonderful PTO day. You're in Texas. You're in Mountain, right?
I'm in Detroit actually, so yeah, I'm on.
You're
Eastern.
in Detroit. You're in
Yeah.
Eastern. I see. You don't have to wake up too early. I know. Cool.
It's not too bad. It's not too. I'm happy to do it because really I'm super excited to see the cluster API community kind of like get into Karpenter a little more. And I think there's a lot of cool possibilities, and it'll be really exciting for people in the CAPI community because you know Karpenter is it's really exciting a lot of people about node auto scaling or node provisioning, however you want to call it these days. Like so. Yeah, thanks everybody for coming out, especially big thank you to people who had to come outside of their normal working hours. And I guess, yeah, we'll talk in the regular CAPI meetings.
Thank you, everyone.
All right, yeah.
Thanks, Mike.
Oh, thank you.
Have a good
Bye.
one.
Bye.